A very warm good evening to everyone. And today we have, shall we start the session now? Shashwat?
Yes, ma'am. Sure, sure.
Okay. So I'm delighted to welcome today's speaker. She is an amazing person and amazing teacher also. Apart from that, she holds a number of degrees. And let me introduce her. She is Lieutenant Dr. Rakhi Thareja, Associate Professor, Department of Chemistry, St. Stephen College. She is an Associate NCC officer also. She has done her PhD from University of Delhi in the her expertise is in computational chemistry and physical chemistry. She enjoys using her basic concepts to gain insight into the modern chemical research with interdisciplinary approach. Her communication includes molecular modeling and simulation of quantum dots. She has published several papers in international books of repute, and during the pandemic times, she made full use of these virtual tools to train her students. And we look forward to gaining more insight into the virtual field and its applicability from the upcoming talk. So we welcome you, Rakhi, and please enrich our students with these virtual tools and how chemistry through virtual labs can be done.
Thank you very much, Dr. Karan. I would request the participants to mute themselves. I'd like to, on the very forefront, I mean, before I begin with the lecture, I'd like to thank Dr. Kiran for such a, what do I say, generous introduction of mine. Thank you very much, Dr. Kiran. Now, without any further ado, we always have all the time on earth to talk virtually and otherwise. Let's move on to the virtual world. As I can see that majority of students have already joined in on this virtual platform, I am laying more and more emphasis on the word virtual because during the pandemic time, we realized the importance of these virtual. We realized the importance of the term virtual.
Just a minute, I would like to, just a minute. Deepika, please mute yourself, beta. Everyone, please mute yourself.
And Shipra Srivastav also.
This actually brings the speaker out of the train of thoughts. Please don't do that. I'm so sorry to interrupt you. Please start.
Not at all, not at all. I mean, this is something which we can talk about in my next lecture when we talk about the pros and cons of the virtual world in comparison to the real world. And we all must learn how to live in chaos. But despite that, I will also throw some light on the netiquettes. You know, these days we just don't talk of imbibing of the etiquettes, the basic social etiquettes that we generally talk of, but rather than etiquette, students are now being taught netiquettes as to how to behave in the virtual world. Now, this has become equally important, especially during the pandemic times. I was talking about this particular fact when there was a lot of randomness in the meeting, that I'm laying a lot of emphasis on the word virtual. Why did I lay a lot of emphasis on this word virtual? Because this has suddenly become very, very important during the pandemic times. And let me tell you, it is not because of the onset of the pandemic times that we actually moved to the virtual world. The efforts were already on, and thankfully they were on. Yesterday, you heard Professor Bakshi, who did acquaint you with the flipped model, the blended learning tools, the chalk and talk methods, and they talk about the various salient features. Right. So, when we talk about a particular type of a classroom, it has its own advantages as well as disadvantages. Right now, I think since this is the beginning of the lecture, I'm sure that everybody is sitting awake and listening to me right away. Let me just make you exercise your hand muscles a little and just let me know how many of you are sitting on table and chair presently. Just write me if you're sitting on a table and chair properly to listen to this particular lecture. Let me just see. Put it in the chat box and I'll get to see that. This is an open question. Good. All right. Around 10, around 15, around 20. Now, yup. Does it mean that you're sitting on table and chair? Around 35, 50. Sitting with a table, proper table, chair, and sitting like as you would have in the real world in your classroom situation. Had I come to your college and given you a lecture there, you would have been sitting on proper benches in the lecture theater and listening to me, right? Without even doing any talking to anybody else. Not me. Somebody is being very honest. Somebody, and again, Manish is being very honest. He's written no, ma'am. So, see, when we talk about making use of the virtual world, it's giving you the advantage of, just listening to a particular lecture from the comfort of your quilt. Now, what is the difference between sitting in a quilt and, sitting on a table and chair? I am not talking about netiquettes here. It's absolutely perfect and absolutely fine as long as you keep this active. As long as you are keeping your brain muscles active, there is just no harm on working on a virtual mode. But remember that you may imagine yourself virtually to be the topper of the university. You may imagine yourself to be winning a Nobel Prize. But what is the point of just imagining it virtually unless you prove it in real? So remember that virtual remains virtual unless and until you actually take it down to the real lab. But when we take up a problem right at the very onset in the real world, there are a number of hurdles that need to be crossed. Now this is what the virtual world helps us in. Before I start showing up my presentation for today, I would like you to understand the meaning of the term virtual, which has become quite clear to you, and you would better define it than me. When we talk about something happening virtually, means that it's not happening in a face-to-face manner. It is not happening in the offline mode. It is not happening in a physical appearance manner where we can actually touch and feel, right? Virtual means that we are just interacting through some kind of a platform where we can see each other, but unless given a choice, you cannot speak up. If the host restricts your right to unmute yourself at the present moment, let me tell you, it will only become a monologue and not a dialogue. Somebody has just proved me right. So, and just in case, if I ask you a question, you would have a particular platform, like in the chat box, you just replied to me, right? So there are a number of ways of conducting a dialogue, but virtually means that we can just interact with one another. All right, that's one thing. Second thing is, what are we making use of? We are making use of the Zoom platform right now. We have many similar platforms that are available for interaction. These are all virtual platforms. Why? Because we are remotely using a third-party source by making use of internet to interact with one another. So here we talk of making use of some kind of a software that has already been prepared for us. So this Zoom platform is already prepared for us. But unless and until I explore each and every button, each and every option, how to do the screen sharing, how to use the chat box, how to mute and unmute myself, I would just not know how to use it. Right? So that comes in from the basic knowledge that you've gained ever since you were in school, right? You know English language, you know how to click a button. So anybody, let me tell you, my mother-in-law who's 80 is also very, very tech savvy in the sense that she's absolutely comfortable with Google Meet, Zoom platforms and all, where she attends her meetings of her sort, which are of interest to her. So it's not about a question of gaining knowledge. It's about having a prior set of rules with you where you should know what all buttons are to be used for your own purpose. You should know the aim for which you are actually doing a particular thing on screen. If you're sitting right here, right now before me, you are sitting here to listen to me virtually, but simultaneously there is a purpose for attending this chemistry meeting. Why? Because you want to learn more about the subject. You want to enrich yourself in the subject that you're actually doing. So in order to enrich in a subject that belongs to the sciences, let me tell you, you just can't restrict yourself by remaining stuck to the theory. You need to move a step beyond theory. Now, the biggest hurdle that actually came up to the science teachers was that, all right, theory can still be taken care of. We use the Blackboard for interaction otherwise. So when we use the Blackboard for interactions, it's like, the same thing as nowadays we use the Jamboards or the screen, or, we make use of the whiteboards online and just show you whatever we would have written otherwise. Now, there are a number of factors that you are missing upon. Virtually, you need to be attentive to what is being taught in a very bright manner, because otherwise, we cannot check you out unless you put your cameras on. Now, putting cameras on these days give you a brilliant reason, of quoting that your data gets utilized to a great extent. So majority of the teachers don't insist upon the students opening up their cameras. So it's just working on a faith basis. So again, a virtual. I am virtually assuming that you all are paying attention to me. So you're getting the meaning? There is a difference, big difference. The hurdle that I was talking about, that majority of the science teachers had to face, was how to train our students now practically. Because how to hold, a burette, a pipette, a conical flask, how to make sure of the lab safety protocol that you have to follow when you enter the lab. That training can be told to you, but it's easier said than done. When you actually practice it practically in the college, in the lab, is where you learn. You are taught that A stands for apple, but unless you visualize that apple right before you, it becomes so difficult to imbibe that apple is an apple. Okay, so what I want to tell you is, like, first thing that is very important is visualization. And the second thing is that when you have a physical bearing or a physical touch of the particular thing, practical implication of what you're doing. Okay, teachers can tell you how to hold a pipette correctly, but unless you use your own hand muscles to practice it out in the real lab, you would not understand as to how to go about using it. Getting the point? So let me tell you, there was one thing that at least got eased out then. That was the introduction of the virtual simulators. Now, word virtual is already clear to you. Whatever is happening in the non-real world, happening in reality, is your virtual. But when we talk about simulators, what does a simulator mean? Right now, I'm holding a pen in my hand. All right, I'm opening up the pen, closing it. If I am able to, alter the behavior of this particular small non-living object, I am simulating it. So whenever you bring about, and if I'm able to do that on screen, I would say that now I'm carrying out the simulations virtually on screen. It is some kind of an imitation of the real stuff on screen. So when you talk about simulations, it's something that imitates your real world on the computational screen that you're working with. So understand the meaning of simulations. Simulation word is also used when you draw your chemical structures online, but you still call it simulation. Now you would say working on a virtual lab is also simulation. Working with the structures that are drawn on screen is also a simulation. Whatever behavior or whatever behavioral pattern can be changed on screen is basically referring to simulations, because simulation refers to the imitation of the real world computationally. Understand the meaning of it? When I'm talking about simulations, I am talking about doing something which is happening in real on computer. So right now, even in my, I have chosen up this particular template for my presentation so that you can see the water moving throughout. This doesn't mean that I have actually put water on my screen. There is a particular software that is helping out this animation to happen in the PowerPoint. So that is enabling this water or this free template, which is able to, show you the animated form of it. So that's why this is also simulation of water on screen, but I am not simulating it. This is already there. So now let's come down to our virtual experiments that you perform online. The virtual experiments that you have already learned, many of you have tried it out also. I'm glad to know that you tried using the acid-base features. I'll show you some of them by making use of other virtual tools as well. So what you can do is you can prepare acid online. Wonderful. Without spilling it over, without having the tensions of having gloves and all the safety protocol, you can just prepare acid on screen. You can neutralize it with the base. You can check out the pH on screen. So basically, all of this without having to buy the chemicals. So your virtual practical lab is absolutely free of cost. It only involves the internet cost, which you're even using to play your PUBG and Among Us and other games that you play on with. So you're utilizing it even for studying now to enter your practical lab on the virtual screen to imitate. That means you are simulating the behavior of what you would have done in the real lab, right? So it's absolutely free of cost. You don't have to put in any chemicals. But yes, otherwise in the real lab, you would have taken in order to prepare a standard solution, you would have taken a chemical, you would have had to take the apparatus and prepare it according to the protocol that is given to you by your inorganic teachers. That is how you go about using it. Here, it's absolutely free of cost. Then, if I am preparing one solution right while being here in Delhi, many of you, even while staying outside Delhi, are able to prepare the same solution on the same platform, right? You are able to prepare the same stuff. So it's easily accessible from anywhere. Even if I would have planned a trip to Manali at the present moment, I would have been able to just work on the virtual lab anywhere. Even if ma'am would have given an assignment to anybody from anywhere, it's easily accessible. The only thing that should be there is that I should have the accessibility to the website, as well as I should have a working web. Next, it's a self-learning mode. Even if sometimes your teacher just introduces you to a particular virtual lab, here you have learning mode, which is absolutely applicable. You can just go about checking up the free tools. Like, for example, there is a website called Labster, Labster, labster.com. When you actually enter this particular website, this teaches you the very first basic thing that you need to follow when you enter a lab. Now, let me ask another question from all of you. How many of you have never visited your college lab till date after joining graduation? Just write never in the chat box if you never visited your college lab till date. All right. All right. Many of you. That's tragic. But then let me tell you, when we were preparing these virtual simulators to be practiced online, the idea behind it was not to actually expect a pandemic so that, you get introduced to it immediately. The idea was to move to the flipped classroom and the blended learning models that Professor Bakshi had talked about yesterday. What is that? One of the models suggests that I give you some kind of an exercise. So if we were planning to prepare or carry out, say, a pH metric titration tomorrow in college, what would I have done? I would have introduced you to this virtual lab, given you the link of it, explained the methodology to you, and would have allowed you to practice it online. When you practice on the virtual simulators, you get an idea as to what all problems can you face. You get so many questions in your mind, because a true scientist always has an inquisitive mind. By the virtue of being science students, you should always have questions whenever you're carrying out something. If you do not have questions, try to create them. What all things can be done? How can you innovate the experiment? If you're not able to find the answers, keep exercising your brain muscles. Okay? Lest they get rusted. So that oiling needs to be provided. So what happens in the ideal learning mode, which we wanted to actually adopt, was like, I would have taught you the basics of the particular experiment. Basic means that if I want you to carry out acid-base titration, then for the acid-base titration, I should give you the chemical equation, make you understand how it gets neutralized, how the acid gets neutralized, when will there be an inflection in the pH metric curve, and how to take down the readings using the pH meter. I would have allowed you to go back at home, work with the virtual simulators, and come back the next day with questions in your mind. That, ma'am, when we did it virtually, we could have actually added acid to base rather than adding base to acid. Then why are we not using an indicator in that case? Why should we or if at all we are using an indicator, why are we using it? All right. When you then take it to the practical world in the real lab, there you need to adjust your burette vertically on the clamp stand. That requires expertise. When you put your conical flask on, or say the beaker for the pH meter case, if you're putting the beaker, how much the beaker is to be filled, whether the electrode is getting dipped into your solution completely or not, all of these questions additionally come to your mind if you have a preset protocol of the basics already clear to you. That's why many of your teachers also tell you at times, come prepared to the classes, come prepared to the classes. When I was a student, I always used to keep feeling that if you have to come prepared, then what's the point of actually having a teacher to teach us? Hota hai na? Aise many of you also do get this question in your mind, that why is ma'am asking us or sir asking us to prepare and come for the lecture, to prepare? If we are already prepared for a particular topic, then how or what is the purpose of sitting for a 1 hour lecture? You need to prepare yourself for the questions that actually arise. And that is precisely the meaning of having virtual simulators. But thankfully, during the pandemic times, we could get introduced to these virtual simulators in a, by and large, very broad fashion on a very large scale, now renowned virtually and globally used. And many of the universities, have participated more or less. We'll talk about them. You can innovate experiments because, when you work on virtually from the comfort of your quilt, rather than, opening up any website, gaming website, I think it is better as a science student to just fiddle around with these experiments and start having fun with them. Fiddle around, spill over. Like I said, that I got introduced to Labster very recently, and newer websites are coming up with these virtual simulators, which are just fascinating. With improvements, they are actually creating that real-time world. When I was working with it, I suddenly spilled over a bottle. It immediately gave me an indication that I spilled over a bottle and I need to rush to the flush tank where I need to splash water into my eyes. So you get to know about how to behave in the real lab, because we do not want any accidents, we do not want any kind of wastage of chemicals. We want to live in a green world. Understand, we talk about green chemistry also these days, which is floated as a part of your SEC and DSE as well. There you are learning to minimize the use of chemicals. So these virtual simulators are also helping you in minimizing the use of chemicals. Okay, so we talk about innovative experiments, and of course we can use it anytime and anywhere. So the inspiration is that, what you can do, as I told you, that you can use it during the pandemic times freely from anywhere. There is distance learning absolutely comfortable. Say supposedly if somebody is sitting remotely in Kerala right now, and I am talking from here in Delhi, you can comfortably understand the same things at the same place, or at par with other students who are sitting in the comfort of their homes comfortably. All right. Then you can also understand the quality of lab work which needs to be taken to the real labs when you enter the real labs. So at least prepare yourself mentally. I understand it's quite tragic and ironical that you've not been able to work in the offline manner owing to the current pandemic times, but at least prepare yourself so that when you move to the real lab, nobody should make out that you're working for the first time. Okay. The data that is generated, let me tell you, are based upon the kind or the quality of the programs that are there in simulators. Now, say supposedly want to generate data. There was a question that was put up in one of the talks by one of the students. I really liked it. He said, ma'am, how do we put in the temperature conditions? Wonderful, because when you're working on computer, you don't put your computer onto the flame to take the temperature high. You have an option of temperature. But then how is the temperature increasing for my chemical systems online? Okay, that's a question. I'm also putting that question to you. Just think about it. When you are carrying something virtually, in the real world, sometimes we need to heat certain chemicals also, right? And then carry out the titration in order to, speed up the reaction. We do that. Now, when we have to increase the temperature in order to generate data, what do we do online? Somebody would very comfortably say there is an option of temperature. Baba, if there is an option of temperature, would you put your system on flame, and is it increasing the temperature like that? Do you feel the heat on your system to the same level of temperature that you are setting your system or software to? No. Why? Because here your chemistry plays a role. Understand the basics of what you have learned. You know that kinetic energy is directly linked to the temperature. So what we do is we alter the kinetic energy of the molecule. We make use of what you've studied in gaseous state, solid state, and liquid state in the first semester itself. And we use those equations into the program so that the moment you set the temperature, it will alter the kinetic energy, and hence the temperature will be working accordingly and the behavior of the molecules will change accordingly. This is how theory works in coordination for computational chemists to be able to create programs for you. And for you, it is as simple as just, pressing or click at the click of a button, you get everything. That's simply because, the software or the program is created like that. The virtual simulator has been created in such a fashion where you just check out on the temperature and you get your results accordingly. So the data that is generated, in order to be highly reliable, should be generated from the same real lab conditions that you can create virtually. Okay. Then, the objectives of the virtual labs is something that can be talked about. I told you there is a remote access to the labs, even if, at times you need to miss your lab. But in order to remain at par or with the knowledge that you have, you can have a remote access to these virtual simulators to check out the principle of what you have learned. All right, it caters very well to not only the UG, PG, and research level students, but all of the engineering fields. Let me tell you, I was mesmerized to check out that students in mechanical engineering, civil engineering, biotechnology engineering, biomedical engineering, all of them are using these virtual simulators to make sure that they understand the working. Because these virtual simulators, they make you pick up the conical flask. All right, you're not doing it in the real world, but you know how to pick up the conical flask. The nitty-gritties of it will be learned when you move to the real lab. So you pick up a conical flask, you are adding up the solution to it. All right, then you are placing it on the workbench. The workbench is also created according to your real lab environment, and then you are carrying out the experiment further. So to keep that innovation spirit on, this is something, or this is the workshop that I think you have correctly joined in for. Okay. Right. So after that, one thing which is very, very, very much advantageous for these virtual simulators is that the cost factor is almost negligible. I told you, no chemicals, no spilling over, no wastage, no lab staff required, nobody to make you get into a queue to collect your apparatus and submit it back. But you would have enjoyed it in the real lab, I tell you, and you would get that opportunity very soon, hopefully. It works on 24/7. See, in the real labs, you will have a protocol that, like your labs get opened at 9:30 and they will function only till 5 or 6 p.m. in the evening, generally for the college students. But here for the virtual simulators, even if you have an idea at midnight, you can straight away open up the simulator and try it on with the kind of conditions. Yes, you have to remain within the restrictions of the software or simulator that are being provided to you. There is a wider outreach, of course, and it is safe and efficient, has already been told to you. Now, this is the time when I'm telling you whatever you do virtually, kitna bhi virtual world chala lo, but unless you prove it in real, there is no point. So this is the time when virtual and real need to join in hands. Many of the people were wondering, oh, how come the vaccine suddenly got developed in such a short span of time for this pandemics? It was all pre-planned. But let me tell you, I do not want to comment. This is another debatable issue, whether these pandemic times were planned or not planned. But let me tell you, this is the time when we've appreciated the virtual world joining hands with the real world. Because me being a computational chemist, let me tell you, we create molecules online. Okay, we create molecules online, but then, as I told you, I may keep creating online molecules. But once I state that, okay, this is the drug that is efficient to treat your coronavirus, can I give you that pill also virtually? Can you have that pill virtually and just work with it? No, I need to actually take it to the real world. right? So in chemistry, and as chemists, let me congratulate each one of you. You have the option of creating as many molecules as possible, unlike the historians who cannot create their Akbar again, right? You're getting the point. They cannot visualize what they study on paper, but you have that option of doing whatever you are studying virtually on screen, create new experiments, create new molecules, and take them to the real lab, and then check out. Say you can take about 3 or 4 protocols to the lab. Out of those 3 protocols, the best one will definitely yield the best of the results that you can think of. And that's possible for your inorganic experiments, organic experiments, as well as physical chemistry experiments. And in addition to that, many more. This is an interdisciplinary world. You can think about as many experiments as you can. All right. So this is the time for that breakthrough that we can actually think of. First, even for this vaccine development, the models of the molecule were created virtually, they were tried out, and the feasibility was checked accordingly, and then they were taken to the real lab. So what happens, it reduces the time that is involved, or it reduces the labor that gets that needs to be put in the practical lab. When you're doing something virtually, you have the flexibility of working 24/7. That's one thing, but all work and no play, makes Jack a dull boy. So you need to have breaks also. Like I said, if I get time, I'll talk about etiquettes also. So what is done is, like, you can make your system work throughout. I put a reaction here in the virtual simulator, and I can just go up, have a glass of water, and come back without having any tensions that anything can go wrong in the lab, because this is a virtual lab. Even if something goes wrong, you can always reset it and start it again, right? If you fumble on storing your data, there is always an option of keeping a backup here, which is not possible otherwise. Okay, so many of these things can actually be talked of when we talk about real versus virtual, which is my next lecture in some days from now. The magic of virtual lab is all based on modeling and simulations. Now, I made you understand the meaning of simulation. What is the meaning of simulation? That whenever you are altering the behavior of the real world on screen, simulation means that you are bringing about some changes in your molecules on screen. That is what simulation is all about. And modeling is that you are creating real models virtually. So you have some kind of a setup of a distillation apparatus. You are creating the same apparatus on screen and then bringing about simulations so that you can fill in your distillation apparatus. You can set it on flame. You can check out the output model accordingly. So the virtual labs that chemistry experiments work on are based on modeling and simulations. Then comes the next part, which is based on measurement that you are made to do as a part of your assignments. And then it is remotely triggered. I may be working with University of Manchester, the simulator that they have created for me while working here in India. And the results are being monitored at some other place. So understand that if you have a remote trigger to it. All right. The broad areas for virtual labs, as I told you, for chemical sciences, it is like we are understanding the use of it. It can be used for physical sciences. I told you all branches of engineering that I've put on here. And there are a number of nodal offices created throughout India for the same, because this is the time when we want the creation. I'll take up questions in the end. Ritvik, have some patience. I'll just quickly go through. Okay, so right now, when I'm talking about these virtual simulators, there are many universities which have collaborated with MHRD, Ministry of our Home Resource and Development. So here, research and development. There, let me tell you here, when we talk about the collaboration with MHRD, institutions and universities like IIT Delhi, Madras, Kanpur, Kharagpur, Chennai, Guwahati, Roorkee, and then Amrita University. You must have heard of Amrita Labs. So all of these are working for the benefit of the student to even learn remotely. Let me tell you, all right, you guys are really privileged. All of you students who are listening to me, most of you are very privileged, because if not today, tomorrow your labs will open up for you to work in the real environment. But till date, there are many remote areas in India where, even in graduation, students don't get an access to the labs. And this is something that would opens up a new world altogether for them. So there are many universities which are working, and you call them the learning management systems, which are developing as a part of your LMS. So, virtual labs are basically bringing about that integrated type of a learning. So do not think that virtual lab simulators are playing a role only during the pandemic times, because we cannot enter the lab unless we follow the social distancing and the norms of the COVID that we are generally made to follow these days. Remember that they were created for a larger purpose. They were created for having some kind of an understanding of the real lab world online, so that if the child also feels like repeating a particular experiment, you have the option of doing that. So on demand labs can be created depending upon the programmers who can actually bring about computational chemistry into play to create that kind of an integrated learning. Then you can self evaluate. There is a freedom to learn here, make mistakes without feeling embarrassed, and then you can improve upon them. You will learn from your own mistakes even virtually. And let me tell you, when you take it to the real lab, the number of mistakes will be less. Although I'm not saying that you will be 100% perfect, there will be a scope of improvement there as well. But then the wastage, the kind of understanding that you take to the lab, will make you feel more knowledgeable. And when you have that knowledge, let me tell you, the outcome is always brilliant. Okay, then growth of the virtual labs is of course stable. Let me tell you, I think number of students in India that have been trained have almost passed 3.5 lakhs in last year. And the number of students getting trained now, similarly, in order to train the students, the teachers need to be trained in first, right? So there are thousands of teachers who also keep getting trained every year for this. So that number is also increasing slowly, steadily, so that we're able to train students, because there should be somebody to make you get aware of what these virtual labs are also all about, and then make you work with these simulators. So the kind of self-learning tutorials that you are exposed to are really brilliant. And the number of workshops that need to be conducted, they need to be speeded up further, because in this fast moving technical world, unless one is aware of these tools, you actually lag behind a little. Say if one of your friends has already practiced I'm sorry, a particular experiment, then that child will be far ahead of you while working in the real lab. Just excuse me. As another part of an etiquette that I was thinking of while having water, is that always keep the necessary things around you when you're working on a virtual simulator, so that you don't need to get up again and again and have a break in your thought process when you're working with a virtual simulator. So keep your necessary things around. That really helps. Otherwise, I would have given you a break of more than 2 minutes now. Okay. So one of the workshops that you are being a part of for virtual labs is already being conducted. Now, I was going through the experiments that you are exposed to. Majority of you have already downloaded and installed the VLabs, right? It works with Windows as well as Mac OS. So majority of you must have already started working with it, which is going to be really brilliant. There are a number of chemistry experiments that you can work with virtually. And I have put some of them on screen, picked up from one of the websites only. You can work with acids and bases, advanced acid-base techniques, atomic structure you can get to learn. You can learn about the basic thermochemistry experiments. You can learn about chemistry safety, as I talked about Labster this just at the beginning of the lecture. And then apart from that, what is now the crux? If you are doing a particular experiment, in the online mode virtually. I can talk about the click and click of a button to anybody. Let me tell you, I can train lab staff. Forget about the lab staff. I can teach that to my child who is 8 years old presently, right? I can just tell her, because these days kids are very tech savvy. They all are exposed to the technical world, thanks to the present times. I mean, they're all exposed to the technical world. And, if I would face any problems on any of my meetings, they're the first one to pump into my room to just help me out with the same. So if it is just a click and click of a button, I can always put the protocol on a piece of paper, tell them, go to this drop down menu, click on pick beaker, fill in with the beaker. I am talking about my 8 years old without exaggeration. Fill in the beaker with a particular solution. And now, after filling it with that, add, the solution from the burette dropwise and keep recording the data. I can do something like that. And let me tell you, she will be absolutely efficient in recording that sincerely. But what is the difference between an 8-year-old child and a child who is doing graduation is that you have to make use of the knowledge that you have imbibed in all of these years. What do you do with the data that you observe? You have to make use of that data. And then once you actually get that data, you should be knowing how to interpret that data. Now you will be in a position to interpret that data only if you are well versed with the theory of a particular experiment. Say if I am talking about a neutralization reaction, I should be knowing that my acid and base react to give me salt plus water. That should absolutely be clear to you. If I am talking about the preparation of a standard solution, the things that should be clear in my mind: what is a standard solution? What is the formula of molarity? Whether I am preparing the solution correctly of the known concentration to the correctness of what the system is asking me to do. These are the things that need to be kept in mind prior to working with the virtual simulators. And once you have prepared, just think about it. What do I do with this data? Should I just put that data? Should I just put that data in one corner and keep it there? Another thing is that we can also talk about dilutions and pH measurements. Okay, I have learned about acid and base neutralization. Now, what to do with the pH measurement? What is this pH all about? It is the power of hydronium ions or hydrogen ions. So then you should know the formula. It is minus logarithm of H plus ions. How to calculate the pH, and then how to make use of that result, that graphical technique, by making use of the tools of MX Excel and other things. So I'm telling you that the basic virtual simulators can be handled by just anyone if you are told the protocol. What you need to appreciate as chemistry honors students or as science students is that you appreciate the outcome, the data that is being generated. You should appreciate that and interpret it accordingly and check up what you've learned in theory. Is it practically coming out to be true or not? Okay, another experiment that you have done is variation of pH by common ion effect. Okay, this is another one. I have gone through the list of experiments that you've actually worked with. Another one that you worked with is variation of pH by common ion effect. So for that, you should be aware of the common ion effect, that it suppresses the dissociation of a weak electrolyte when a strong electrolyte is added, having an ion in common with the weak electrolyte. Is it something new that I'm talking about? If you have forgotten that, let me tell you, you are getting victimized to the present times. You are getting and taking the comfort of the quilt way too much during winters, or the comfort of sitting, in a very, without following the etiquettes that I'm talking about, in a wrong direction. You do not have to make your mind get rusted. In order to provide oiling to it, make the best use of the virtual simulators, generate data, but you should be aware of the basic terminologies that you have learned as a part of your graduation course. So if I am talking about the preparation of if I am talking about what the common ion effect, as I told you, the basic definition of the common ion effect should be brushed through. One line, easy meaning you can easily understand. Then, apart from the common ion effect, what aids the common ion effect is your Le-Chatelier's principle. You talk about the Le-Chatelier's principle. When you talk about that, it always tries to oppose the effect that is brought to the reaction at equilibrium, right? In simple language, I'm just repeating the Le-Chatelier's principle to you. What it tries to do is it tries to oppose the effect of whatever is brought about to the reaction at equilibrium. So if I try to increase the concentration of the reactants, it will try to decrease it by moving forward to create more products. If I try to increase the concentration of the products, it will move in the backward direction to decrease the concentration of products, right? If I increase the temperature, it will move in the direction of the endothermic reaction. So now these terminologies, endothermic, exothermic, should absolutely be there on your tips when you move to the real world lab. And that is why, in order to brush through them, in order to provide with the oiling, proper oiling to your brain cells, let me tell you, virtual simulators are created for especially the science students. Okay, understand that? Then apart from that, so when you're talking about the Le-Chatelier's principle, let me just complete. When you decrease the temperature, you actually the reaction tends to move towards exothermic reaction. Because what happens in the exothermic direction, the temperature increases, the heat is generated, right? So when the temperature is decreased, the reaction proceeds in the direction of exothermicity. When the temperature is increased, it moves in the direction of endothermicity. Basically, Le-Chatelier's principle opposes any change that is brought about to my reaction at equilibrium. So these basics need to be revised before working with virtual simulators. And let me tell you and make you feel confident that whenever you have to revise any basic concepts, all you need to do is just given about 10 to 15 minutes. 10 to 15 minutes are also way too much that I'm asking for. You would require, because I know all of you all are very, very intelligent, all you need to do is just go through them a little and revise those concepts that you've already learned during the classroom, especially the virtual classrooms. Okay. Majority of you are working like that. Now, again, I've told you that when I have to set in real conditions, what do I do? For setting real conditions, I set room temperature. In order to set the room temperature, I'm not putting my system on flame. I'm repeating it again. If I have to add solvent medium, I am not going to put that solvent medium on my virtual screen. Please don't do that. Okay, this is totally not to be done. Okay, so how do you introduce a solvent? Now the question is that temperature to chalo ma'am ne bata diya that we will alter it according to the chemical equations where kinetic energy of the molecules will be altered. What about solvent? Now, in order to introduce solvent, we'll add the dielectric constant of the medium. Okay, so if I alter the dielectric constant of the medium, it will serve the purpose of addition of the solvent. So I'm just telling you what goes into these simulators. You are adding a solvent. If it says calcium nitrate, why do I believe it's calcium nitrate? What if it is taking NaCl in the program? Let me tell you, all of these solvents, they are associated with some kind of a chemical parameter which is already embedded in the program. If you even do not know how to handle any of the coding languages, like I am very poor in coding, okay, so but still these virtual simulators have made life so simple for me that I just need to click and I get to see the results. Okay, then after that you have also, I'm just telling you what all things need to be revised. For the acid-base titrations, enough has already been said, and you have started using virtual simulators for very basic exercises. Not just that, apart from that, for buffer solutions, you can go through the Henderson-Hasselbalch equation, which is nothing but pH is equal to pKa plus log concentration of the conjugated base upon the concentration of weak acid. So some little bit minute things that you need to revise before working with the virtual simulators, and then keep them handy with you as true science students. Concepts which require not more than, I am telling you, 15 minutes. The minimum that you require is 5. The maximum, if you're doing it at leisure, is just 15. So just make sure that you brush through that basic theory. Thanks to Google Baba, this time, even if you don't, I mean, these, with the onset of, having a smartphone of in your hands all the time, you have an access to Google at all times. It will not take more than 15 minutes, even if you're studying a topic at leisure, to just get acquainted yourself with the basic theory. Do that. Okay. So there are a number of experiments that can be talked about. What we intended to do when we created this virtual simulators, or when we created these virtual simulators, was that we were intending to have a safe and greener environment. Why greener environment? Because it saves in a lot of chemicals which are used in your practical lab. If the students are already well aware of what is to be done in the real lab, by working out on virtual simulators, life gets truly simple because you make less mistakes and you take what is feasible, what is possible, only to the real lab. For basic experiments, okay, you understand that you are told that this experiment is to be done, you take it to the lab. The chances of making mistakes would anyways be less because you're working under the supervision of your teachers. But sometimes when you're doing some kind of a research, when you are not sure whether the yield of the product that you're intending to get will be correct, whether the product that you want to synthesize will be correct or not, then in that case, let me tell you, these virtual simulators help you a lot. All right, because we want all of the future generations to just enjoy whatever we are also enjoying at the present time, in present times. Okay, so here we move on. So the scope of expansion is really a lot. You can develop new experiments. Let me just quickly show you a few experiments rather than throwing more light on the slides that I prepared for you. I've already talked about much of the virtual simulators and given you the gyan that I actually want you to imbibe. The purpose of sitting, the best part of having an offline mode, I think majority of you would love to meet each other offline, would love to meet your teachers offline. But the point is that, why do you want to meet offline? Parents are just thinking that, students are bugged up of sitting at home. One reason, partially correct. But then, apart from that, even when you are sitting in an intellectual environment without feeling much interested, you tend to imbibe the vibrations. And after all, life is all about chemistry, as I keep telling everybody. Life is all about chemistry, and it's not about physics or mathematics or about, biology. You must have heard of the statement, life is all about chemistry. So you can actually imbibe whatever you hear from around, whatever is happening around automatically, and it keeps getting embedded into your subconscious mind. So there is, in the technical world, rapid development, and because of that rapid development in technology, let me tell you, there is rapid development in the real-time practical environment as well. There is reduced need of funding, because earlier we need a lot of funding for the chemicals and the setup and to prepare the safety chambers accordingly. There is global participation. If I think of some innovative experiment and I want to try it out at different regions, I can always make use of these virtual simulators to introduce my experiment to the world. And stop playing games which are just a waste of time at times. Okay, they are rejuvenating, but these virtual simulators are just analogous to your games, let me tell you. So what you can do is work with these virtual simulators, try and keep practicing them, and you will just have the fun of the real gaming experience in the chemistry world. And that is what you are into. So just keep practicing that. All right. And I think much has already been said. Like, when you move to the real world, there are certain things that you should also be aware of, some basic lab ethics that you must follow. And all of these lab ethics are also available online. Like I told you about one of the virtual simulators, I'll show you some more virtual simulators quickly so that, let me tell you, it's as good as, when you work with virtual simulators, you get to know about so many things more. It's like, you understand one language of coding, you can understand all the other languages. Say, I know how to work with C++, Java. I will be able to understand Python also very easily. I will be able to understand any other coding language comfortably. So is the case here. With this workshop, if you learn how to work with one type of a virtual simulators, learning and working with other virtual simulators then would just be like a cakewalk. Okay, let me just try and just check up if you can see my screen. Wait, hang on. Okay, let me just see if I have opened up. Can somebody just acknowledge or put it in the chat box if you can see my screen? I have opened up the Beer's Law apparatus. Okay, tell me if you can see my screen with the setup that I have put on.
Yes.
Okay, wonderful. So here, this is one type of a simulator for your Lambert-Beer's law. I don't know how many of you have practiced working with colorimeters, but see, in this particular case, and this is what you're doing with the virtual simulators. So I'm just introducing you to some more to just appreciate what all things you can do with it. And if let me tell you, in the present date, my daughter, she knows more of Microsoft Paint than me. You know why? Because she keeps fiddling around with it all the day. So she knows what all options are available, where on the options can be clicked from, what all colors. I fumble at times to mix and match the color combinations when I'm using Microsoft Paint for drawing graphs and all. But she helps me out with it, which is, really fascinating. It's not about the age that matters. It's not at all about the knowledge that you imbibe otherwise. It's about your practice also that adds up to your intellect. So keep practicing. That is why, you're being exposed to virtual simulators. Now, in this particular case, say, for example, I want solid cobalt nitrate. So what it does is, let me just empty it up first. In order to empty it, just a sec, I will evaporate it completely. I have evaporated. Oops. But I have some specks of cobalt nitrate already left here. Let them be. Remove solute. I've removed. Now I'm starting from the scratch. Just appreciate if I need to add water, I will just open it up. I have added half liter of water. All right, added half liter of water. All right, now I want to prepare, say, cobalt nitrate. I have many other options also available with me in the drop-down menu. I can prepare a drink mix. I have cobalt nitrate. I have potassium dichromate. Let me just pick up potassium dichromate. Okay, say. So I picked up potassium dichromate. I can use either the solute, or I can even use the solution prepared for the potassium dichromate. The only thing is now I'm adding it just, as if I'm sprinkling salt on some kind of a food stuff. But in order to be sure of what concentration is prepared, I will just put in this checking apparatus into it to check up the concentration right here. You can see that the concentration is what? 0.51 moles per liter. So 0.51 molar. If I want to dilute it further, what do I need to do in order to carry out dilution? Add water. So I'll add water. Let me just make it to 1 liter. All right. A little careful. And this precision would be required in a far better ability when you move to the real lab. So don't take it as easy as, just clicking off a button. It's just fascinating that you get to do what you're doing in real lab. So the concentration has now reduced to 0.36. Now, just in case if I want to concentrate it further, I will evaporate it again. So I'm just evaporating it again. And now this becomes again concentrated to, say, back to half liter, and I get the same concentration again. I can increase the concentration by adding more of potassium dichromate. So there are ways and means of creating, but this thing, don't you think it can be taught to a student who is studying even in 4th or 5th standard? What is the purpose of you preparing the solution in the virtual simulator? Understand how to prepare concentrated solution, what is the meaning of standard solution, and how to check up the molarity of the solution. Okay, and what is the purpose of using a standard solution here? Then, say, if now I move on to some application of, say, physical experiment, say the Beer's law experiment, if I want to check up whether the Beer's law is being followed or not, I have prepared my solution now. So the bench work is done as far as this is concerned. Now I will work with the colorimeter. So I move to the Beer's law experiment. In fact, I could have clicked on continue somewhere here. I can't see continue because it's overlapping with the chat box. All right, let me just proceed straight away from here. All right, I move on to the Beer's law. Now here you already have, I'm sorry. Since it was already prepared, I was working with it, just show it to you. I can actually pick up cobalt chloride, and all I need to do is just click on this source. From where I click and I pass light through my cuvette. This is my cuvette. This is the entire apparatus of the colorimeter, and I get to see the transmittance and absorbance. Now again, without actually elaborating on this principle, this is not a normal class lecture. Let me just tell you that for those of you who know absorbance is equal to epsilon Cl, you know the meaning of concentration, you know the meaning of length of the cuvette, and you know the meaning of epsilon, which is the molar absorptivity coefficient, right? You can all appreciate that when you are noting down the absorbance value. You can keep altering the concentration, as well as you have the option of altering the wavelength as well. You know, I change the wavelength and I can change the wavelength accordingly. I can change the wavelength here, and I have all the relationships which are of use to me for a particular experiment. So there are ways of looking at it. What can you do with the virtual simulator? You will say that only some options are available. But think that if ma'am has given us to study the effect of concentration for a particular experiment, I can even alter the wavelength for a particular concentration and check it out. What is the effect on absorbance? I repeat, if say the experiment that you are assigned is to find out or plot a graph of absorbance versus concentration. So in that case, what will you do? You will take different concentration of a particular type and keep studying the absorbance value. But you can altogether innovate and think of altering the wavelength and the effect of changing the wavelength on the absorbance as well. So just think about the things which are available with you on the virtual simulator node, and then you can work accordingly, right? You alter the wavelength and you see that the absorbance keeps on changing, and you can just study the effect accordingly. And then virtual simulators are giving you a number of options that you would have had to work with by putting in a lot of labor in the real lab. Here, you're just getting to check out the results. So at least you are mentally prepared before entering the lab that this is how I expect the results to be. If there is any kind of a discrepancy, the scientist in you should put in their minds to think about the reasons as to why there is a difference in the results. Okay. Another experiment that I'd like you to get exposed to, I'll quickly show you that as well, is for the EMF measurements. More of it, I think it'll get on too much for you. Here, see, there is an option of temperature as well. Let me tell you, for all physical chemistry experiments, we generally record the room temperature right initially. Why do we record the room temperature? Because all physical parameters are dependent on temperature. So we can't just work without having the temperature conditions put in. So apart from that, temperature becomes an essential requirement for these simulators. Right here, when you're working with the EMF measurements, they become even more prominent. So you can set up the temperature and then, check up the different electrodes. For all those of you who've gone through electrochemistry, can explore and check out more simulators. I would not throw a lot of light on this experiment. Let's talk about it when I get time in my next lecture, but I have already talked much about the virtual simulators and how you can simulate and enjoy the world of virtual simulators. But don't forget the purpose of using these virtual simulators. The main purpose of using these virtual simulators is to create that kind of an enthusiasm and curiosity in you, to get the real scientist and the researcher set in always to think, innovate, be inquisitive, and then come out with the best results for the betterment of the society. All the best to everyone. If you have any queries, you can just put your questions now.
Thank you so much, Dr. Rakhi, for your time. I myself have enjoyed each and every minute of your lecture. And You have taught me a number of ways of engaging the students by saying write me and all. I just say write Y and N. If you have understood, write Y, but that is a very good way of, and they didn't know that you are engaging them, or you are just looking at that whether they are sitting there or not. Thank you so much. I really appreciate you for your giving your time, valuable time, I should say. If there are any questions, I think there are a lot of questions you will have to answer.
Oh, I would love to, because as it is, I could see that the students are responding to whenever I'm putting a question.
Yeah.
So I really love interacting with those audience who are themselves interested. So my pleasure. The pleasure is absolutely mine.
Yog Lakshmi, she wants to know that how to carry out research work using virtual lab, whether the reaction will take place or not.
See, when it comes to research, you have to understand the meaning of research first of all. When you are talking about research, this is like a broad topic. See, you have a particular experiment in hand for which you already have a set protocol with you. The moment you start innovating and putting in your mind, like for example, let me just share one of my students' work. One of the students just came up to me to tell me that, ma'am, why are we carrying out the surface tension experiment using stalagmometer? We use the stalagmometer, we make the drop get completely fall from the stalagmometer. But that child just came up to me to say that, ma'am, why can't we use a burette and make the drop rate so slow? So you know what did I ask the student to do? I asked the student to move back to the bench, try out the same experiment with stalagmometer and do it with the burette. So sometimes the student feels, oh, why did I ask this question? She's given me additional work. But if the researcher in you is absolutely on, it just works. The child went back to the bench. He came back with the results of the burette as well as the stalagmometer. And let me tell you, to our surprise, the results were comparable. And later, one of my colleagues, Dr. Priyanka Thakral, came up with a research paper on it. She could manage to just write and put down the observations put by our students very well, and it could be published. So, the researcher in you is absolutely live at all times. Even when you're working around, keep your scientific mind always alive. And the moment you innovate, think that you are doing something different from what is the normal protocol. That is what is research. So that, just like I said, that you are given an experiment to study the effect of concentration on absorbance, you can think about doing or studying the effect of wavelength on absorbance, and that will really help you out. Think and innovate and think about how a particular thing, as it is, that doing different things is very easy. I am taking a lecture, I am giving a lecture right now. Majority of you may be talking to your parents, maybe talking to your friends, talking on phone, looking into the phone, if at all. That's like doing different things. But the ones who are the real researchers have the habit of doing things differently for the betterment of the society at large. So you can think, innovate, and just think about the outcome that can come up. So that's all research is all about. And you can just do research with any small thing around you also. It may be related to physical equipment, it can be related to working virtually on the simulators, it can be related to any kind of a work which is having a different approach. Even when you're writing a formula, if you devise a new method of writing down that formula, let me tell you, you have researched and come out with a different thing. So that is also what research is all about. Just doing things differently, but related to the scientific purpose is what really matters the most. I hope I have answered your question there.
Next question is of Mridul Matre. He is asking, how can we encourage our teacher to use virtual labs?
You don't need to encourage them. As I told you, that the number of teachers who are being trained and taught about it are increasing rapidly. You should be absolutely thankful to the teachers of Kirodimal College who have organized this workshop for you, especially to get you introduced to this virtual world. So welcome, and I'm sure that slowly, steadily, you will get your teachers to do it. And if at all, sometimes, you are under the restriction of a course curriculum. So when the teachers are following a course curriculum, they are more interested in making you learn the theory and how to practically imply it in the real lab. So there is no scope of time availability. In that case, I think you students are, the torch bearers for us, who need to enlighten us by telling us, ma'am, please take an extra class and take up this particular topic as well that we would be interested in. And I can actually guarantee you that all of your teachers would be absolutely delighted by the thought of an extra class. We'll take an extra class to make you learn extra things which go beyond the course curriculum. Because Delhi University has not introduced virtual labs as such. That's why majority of the teachers have not started taking it up yet. But yes, if you find any simulator which is related to the experiment that you are doing, you can bring it to the notice of your teacher. And let me tell you, the entire platform will be yours.
And moreover, all the practicals are not available on VLabs. No? That is actually it is a limitation. So gradually they are building up. We use this Lambert-Beer law in our protein estimation, Laurie's method. I am using this for third year.
Oh, wonderful.
Yeah,
And
it is amazing.
I myself actually started exploring and getting more when there was a need during the pandemic times. So I should not say that was the necessity, but there was no other option than to engage students at that time. But let me tell you, my dear students, that ma'am is absolutely correct in telling you that there are a lot of, there are a particular limit of experiments. The number of experiments are limited. I'm sorry, I wasn't able to put it properly. The number of experiments are limited that are available as of now. So we are introducing you to virtual simulators so that the ones who are interested in real programming can get into it and make our life easier by creating more virtual simulators.
Good. Next is Dibyansh Adhia. He wants to know that can you suggest some simulation labs where they can practice their lab work?
I think we can have a discussion on this, all the teachers who are involved in the workshop, and probably create a link of all the simulators that are available so that whenever you have free time, you can just sit with those simulators and work. So I am sure Dr. Kiran will help you out with the same.
Yeah, sure.
We'll share the links and all the virtual simulators for different experiments, and then probably you can have a look. As it is, we are thankful to the IITs here in India who are doing a lot of work for the same.
Even some other university, Amrita University, they are doing it. They are doing it.
Yes.
I think that's all. Thank you so much, Dr. Rakhi, for your time and answering the questions and giving such a beautiful session.
Thank you so much, Dr. Kiran. I really enjoyed giving this lecture. Thanks.
Okay. Thank you so much. All the students, please fill the feedback form and submit your assignment in the classroom.
Can you please tell about the assignment once again?
Okay. The assignments which are related to the practicals which you have to do on the computer, you don't have to submit that. You have to just do that experiment on the screen. That's it. And the assignment in which some calculation part is there that you have to calculate the density and all that you have to write on the paper and submit in the classroom. Is it clear?
So in short, we just have to do the module 5 assignment and submit it, because other than that are all just practically.
I know. So that is all you have to do.
Okay, thank you, ma'am.
And all the students should join the classroom. That is very important.
All the students must join the classroom because the evaluation will be done there only. And tomorrow the session, you have the this thing, program schedule we have already given you. What you have to do is you have to do according to that 3 to 4 you have to do the modules, or before that also you can do, but we have given you 3 to 4 time. At 4 p.m. we will meet right here at the same platform. You don't have to ask for the link, same link will be working, and quiz will be based on that. So you have to submit the quiz at 5 p.m.
Ma'am, module 6 to 8 they have to do tomorrow. 6 to 8.
Okay, module 6 to 8.
6 to 8. So you have to So you have to learn them before the lecture at 4 p.m. and be prepared to answer the quizzes on the basis of those 3 modules, 6, 7, and 8. We'll meet again at 4, ma'am, right? Tomorrow.
Okay. Any other question anyone would want to ask?
But you guys should join the Google Classroom, because otherwise the point is, if you don't join there, you always keep on asking the things on the WhatsApp group.
Yeah.
And
Ma'am,
you-
please see to the chat box. There are some doubts.
Just a
When
minute.
I'm able to install Java.
How to stop recording? Oh, just a minute.